This is going to be lesson 5.3. Our outcome is going to be finding unit rate, describing slopes, and calculating the rate of change, which is the slope. And if you had me last year, you know we had a special name for the rate of change. The constant rate of change, it was called the CROC. Okay, so sometimes I might say the CROC, the constant rate of change, because that's a lot to write. All right, first of all, we need to know what is slope. Okay, so our first one, the basic definition of slope. It's the ratio of the vertical change to the horizontal change. Okay, so the ratio of the vertical change to the horizontal change. And this should be a little bit of review from last year. Okay. Here's what it kind of looks like here. And I want to take you through the step by step. So the vertical change, fraction bar, horizontal change. What does that fraction bar mean? What operation is that? Good, it's division. Okay. Then we can also say the change in y divided by the change in x. Those are the same. Okay. We will hear it referred to as rise over run. The rise divided by the run. And this last one, that's the biggie. That's the formula for slope, calculating slope. y2 minus y1 over x2 minus x1. Notice y represents what? The rise or the run. It represents the rise. The x-axis. On the x-axis, does that represent the rise or the run? It represents the run. So it's the change in y over the change in x. And here's what I was saying about the constant rate of change. The constant rate of change, or the CROC, is also the slope. Okay? You're consistently increasing by something, or you're consistently decreasing by something. And that is your slope. All right. So here's our first example. What type of slope does this line have? Does it have a positive slope, a negative slope, an undefined, a zero slope? This one has a positive slope. It is going up and to the right. So that's a characteristic of positive slope, up and to the right. Let me get a pen here so I can write. Okay. This type of slope, what type of slope is this? As we read, just like we read from left to right, so as we move this way on the axis from left to right, are we going up or down? We're going down. Okay, so this slope, this one is negative slope. Okay. Now we have two very special cases here. Okay, so as you read from left to right, what's happening to this graph? Are we rising at all? No, we're just running. We're going from left to right at a flat, consistent pace. This one has a special name. It is zero slope. We're not rising at all. We're only running. And for this one, it looks like this. Our rise is zero. Our run it's forever. It's a line. It's continuous. It can go on forever. What I do want to show you is that if you put a number into your calculator, so rise would be 0 divided by forever. Now let's just give it a number. Okay, say we went 1, 2, 3, 4 spaces. Okay, I'm just picking any number. If you type that into your calculator, 0 divided by 4, if you have one, I would go ahead and do that. See what comes up. You get 0. You can't divide, there's no groups. You can't divide 0 into any groups. So it's 0, which is zero slope. And that is, as you read from left to right, it's just flat. And that's a special case. Here's our other special case, when it goes straight up and down. So straight up vertically. Okay? This one is called undefined. Okay? And this is why. This is what I want you to look at here. Our rise is going up forever. It could continue on forever, and it could continue this direction forever. But our run, are we going left to right at all? No, it's 0. So again, instead of forever, let's pick a number. Okay, let's say 5. All right, so say we rise 5. 1, 2, 3, 4, 5. Okay, and our run is 0. Type 5 divided by 0 in your calculator. See what you get. It should say error. You can't do it. You cannot divide five apples into 0 groups. That's not possible. Okay? And like what I like to think about is that this is Spider-Man. Okay? Actually, this is me. Can I scale this wall? Can I climb that wall? No. I'm not Spider-Man, so I can't do it. So it is undefined. All right, now we need to actually calculate some slopes. Here's how we calculate slope. Take a moment, pause this, write it down. You have to have 2 ordered pairs, okay? So something that looks like 1, 3, that's 1 ordered pair, and then maybe you have 2, 4, okay? I want you to stack them on top of each other, okay? So right now they're side to side. So what I would want to see is 1, 3, and 2, 4, okay? They're stacked on top of each other. That's what I mean by that. Because we're going to label these nice and neatly, okay? So that we know exactly who's y2, y1, x1, and x2, okay? And then you're going to plug it in and solve. I'm going to show you how to do that in the next slide. Okay, 2 ordered pairs, stack them, we're going to label them, and then we're going to plug in and solve. All right, here we go. So from this, let me get my correct tool. All right, you can see me. Y-axis, x-axis. We need 2 ordered pairs. Well, I got my little dots here. I need to look for perfect intersections. There's going to be one there at 0, 2. And then here's another one that is a perfect intersection, okay? I can get those 2 ordered pairs, all right? And that is behind this screen right here. Here they are. This one is 0, 2. This one is 3, 4. So that was step 1. What was step 2? Stack them. So I'm going to take these 2 ordered pairs and I'm going to stack them on top of each other. Now I need to label, and this is what I want you to do. I want you to create a matrix every time. I want you to label your X column and your Y column, and then this is going to be ordered pair number 1, ordered pair number 2. Because now when you go to plug that into Y2 minus Y1, X2 over X minus X1, you know exactly who is who. Who's Y2? 4. Who's Y1? Follow the matrix. 2. Very good. X2 is going to be 3. X1 is going to be 0. Get our handy dandy formula. Let me write that out because I don't have that here. Okay? This was bad. I should have written this out. Y2 minus Y1 over X2 minus X1. Okay? Then you can start doing the math. All right? Y2, what number is that? 4. Plug it right in. Y1, look at our little matrix here. Oh, that's 2. I'm going to plug that in where it should go. Same thing with X2. That's 3 and that's 0. 3 minus, now we can subtract, okay? All we have to do is solve. 4 minus 2 is 2. 3 minus 0 is 0. The slope of this line is 2/3. Now, listen to me very closely. Unless it divides evenly, you leave it as a fraction, even if it's improper, okay? Because here's why. This tells me I should rise how many? 2. I should be able to go 1, 2. Very good. Now I should run how many to get to my next point? 3. 1, 2, 3. Did I get to my next point? Yes, I did. 2 over 3. That's the slope of this line. It's just a direction, okay? And slope is always represented with the letter M. So M is equal to 2/3. Let's do another one. All right, here's the other one. This time you've been given the ordered pairs, 0, 3 and 3, -2. I want you to pause this for a minute and I want you to try to do it on your own. Ordered pairs, stack them, label them, plug them in. Okay, I hope you've done that. I'm going to do it for you here. Here's my ordered pairs. I've labeled them. I know exactly what column is X and which one is Y. I go across. This is ordered pair number 1, ordered pair number 2. I have my formula, which I believe I forgot to write again. y2 minus y1 over x2 minus x1. Ta-da! y2, negative 2, minus my y1, which was which was 3. So negative 2 minus 3, that gives me negative 5. And then we have 3 minus 0, which is 3. So my rise actually is negative this time. Well, that fits what I said about slope. What type of slope does this have? It has a negative slope, so this number should be negative. This is also an improper fraction, and what did I say about that? I said leave it, okay? Unless it comes out to be able to divide evenly, you leave it. So here we go, watch this. So I should be able to go 1, 2, 3, 4, 5, and over right or left 3. I want to go right 3, very good. 1, 2, 3. Did I end up at my next point? Yes, I did. That's my direction. This is my slope. So m is equal to negative 5 over 3. Here we go. Slope is always rise over run. The biggest misconception or error that people make is they start putting the x's on top. Okay? Be very careful that you always make sure that your change in y goes on top. A special type of slope is unit rate. I didn't do any examples of that, but unit rate is just per how many? Per 1. So if I had 3 over 1, I rise 3, I run 1. There's unit rate. Okay? And then the final thing is that slope is always represented by the letter m. That'll be important with our next video.